Hi guys, in this video we're going to look at sampling techniques and talk a little bit about the large data set, but it's essentially chapter 1 of the first book on the A-level stats program. So maybe you want to pause the video and see if you can match up these words yourself, but here's some key words on the left and what they actually mean on the right. So population, that is the whole set of items of interest. So, for example, if you wanted to get the opinion on the school dinners at the school, the population would be everyone at the school. A sample, so if you think about the example I just gave, you might not want to ask absolutely everyone in the school. You might just want a sample. So it's a selection of observations taken from a subset of the population. So what that means is not the whole population, just a small group, maybe 50 people, 100 people, for example. And you're going to use their opinions to reflect the whole population. A sample frame, this is a key word that you do need to be very familiar with. So this is when you are taking every single person, let's stick with the school example, and giving every person a number. So if you can number everything, then you have a sampling frame. Sampling unit is the individual people in the school, or the individual units of whatever the population is. Now, a census. The government send out a census every so often. They just get information on every single person in the country, where you live, how many people in your house, what sort of money you earn, ages of people, that sort of thing. If you want to do a census at school, you would ask absolutely every single person. A bit like when we get inspected at school, everyone will get sent a survey to do, that's a census. And statistic is a calculation based only on known data. So when we are making our calculations and making decisions on hypothesis testing and stuff like that, we are making these calculations only on known data. It's not a prediction. A statistic has to be known data. Again, there are different types of data, so maybe pause the video and have a go. But discrete data, we would have spoken a lot about this on the course. So it can only take specific values. So you've got a nice picture of some dogs here. So the number of dogs, you can count those number of dogs, so that's why it's discrete. Continuous, that can be any given range. So maybe you're like me at home and you have a nice height measuring chart. Not like that, I just notch it up on the door frame. But heights can take any value in a given range, that's continuous. Words we're maybe not so familiar with is qualitative. So this is non-numerical data, hair colour, stuff like that. And quantitative is what we deal with mostly in maths, is numerical data. So now come on to our types of sampling. So we have random sampling and non-random sampling. You do need to be familiar with both. And there's the key word we talked about earlier, sampling frame. So if you have a sampling frame, if you can number every single person in the population or every single thing or item in your population, you can do random sampling. If you haven't got a sampling frame, we're going on to non-random. So look at sampling, there are three main types. Again, all of them require a sampling frame. We start with simple random. It's when everyone's given a number, like the sampling frame, and we use a random number generator. So on your calculators, there is a way of generating random numbers. You just press it and you keep pressing it and you get as many random numbers as you require. So, for example, how many people are there? Let's say there's 1, 2, 3, 4, 5, 6, 7. We've got 18 people there. So number them all. There's your sampling frame. Let's say we want a sample of 6. We're going to use our calculator. That's obviously a picture of our older calculators. And you press random number. If it was number 5, you take the information from number 5. If your next number is 16, you go and ask 16 what their information is. If you've got a 5 again, you'd ignore it. But you keep going until you've got the sample size that you want. Like it says at the bottom there, repeated numbers are ignored. Systematic sampling. Now, this is when we're going to choose like every 6th person or every 5th person along, and that depends on our original sample size and how many we want. So if we've got 18 again, the same 18 characters, again we want a sample of 6. It makes sense to take every third number, 18 divided by 6. But where do you start? You can't just start at number 1 because then you're always taking that first person. That's not random. So you're going to use your calculator to generate the first number out of 1 to 3. So let's say, oh, that's a slight hiccup on my program there. So, but your first random number would be in the first 3 numbers. Okay, and then you would take every third number there. Only the first 3 because of it's every third number. If it was every 8th number, I'd just do a random number in the first 8. Go from there. It's quite a nice system because you can go all the way along the list. Random, you could have the first 50 people in simple random, but it's unlikely. But now, stratified sampling, strata is actually Latin for groups. And it's when you have natural groups. So, for example, if you're looking at different years in a school, you can see here year 3 has 120 pupils. Maybe we should value their opinions slightly more than the people in year 5 because there's 30 less people. So could we do this fairly? So, if we want a sample of 50, there's 120 out of 310. 310 is all the pupils that we want to ask the whole population. You just find the fraction of 50. We're going to have to do some rounding, just round to the nearest number. It normally works out to equal the number of samples that you want, which in this case it does, and that's how many you would take from each year. But how do you pick out those 19 from year 3? Well, you either do a systematic or a simple random. Any of the other 2 in the other choose. Right, but what if you don't have a sampling frame? So, for example, if you're trying to look at the health of a pond, you can't drain the pond and measure every fish and then fill it back up with water. You can't do it. In a shopping centre, if you want to get people's shopping habits out of them, how long they like to spend online, or whatever it is, you can't ask everyone in a shop to hold still while you give them a number. It's impossible. So when it's sampling frame is not possible, you can only do non-random sampling. So quota. So a quota is when you ask people questions in the street maybe, and you assign them to a group. So maybe their first question is, which age bracket do you fall into? So they might want to ask 10 people in your age bracket. They then ask another 10 people from another age bracket until they fill their quotas. If they do ask you all these questions and that quota is already filled, they just ignore your data. Once that's filled, you don't want to waste your time doing that. Now, convenience or opportunity, it's just what's available at the time. So if you wanted to look at the health of a crocodile, you might not pick that big one right at the back and with the 20 in the way. You might just be like, take the closest one. It's convenient. It might be the first 10 people you bump into. It's not the best. You should be using a quota, especially if there's groups. But it is what has to happen sometimes. So quota is quite like stratified sampling, but one's random and one's not random. Convenience is, we'll see some examples. Right, so it's blurry, but here we go. We're talking about lakes. And there's 3 species of fish known to be in the lake. We've got the numbers up there. 1,400 trout, 600 bass, and 450 pike. And we want 30 fish. So why can't we use a stratified random sampling? So a stratified is the groups, so strata. The problem with that is, although there are 3 types, you can't do anything random because there's no sampling frame. You can't say, hey fish, just hold still, take a number, and we'll call you at random. Like, just jump out into this bucket, it's not going to happen. So because you can't have a sampling frame, you can't do anything random. So there are 3 different types, 3 different groups of fish. So think about the non-sampling method. You want to do quota. It's going to take some time, but you want to do quota. And the advantage is you get to survey all the different types of fish. So you're going to look at the trout, the bass, and the pike. The disadvantage, you've got to catch them. It's going to take quite a long time to fulfill that quota. Now, so how would we do it with 30 fish? So, like the stratified sampling, you'd need to work out the fraction of 30 for each one. So 17 trout, 7 bass, and 6 pike. Now you know how many you need to do in your quota. You're going to have to catch them. Right? You're going to catch them. You're going to assign the data to a quota. And once your quota is full, if you catch another pike and you've already got 6, you're just going to have to release that pike. Maybe you would keep those 6 pike in a container. As long as it's big enough and it's good for the fish, you can keep them so you're not catching the same one over and over again. You'd like to think they'd have a bit of intelligence and go, no, I'm not going near that area again, but who knows? But yeah, so you keep going until your quota is full. It's very important to add that. Right, and that's it for chapter 1. So have a look at some of the questions in your textbook, but it's not a big exercise. It's way more important to focus on your hypothesis testing and stuff like that.